In a previous video, I showed you how to reduce numbers or make equivalent fractions with giving you one of the numbers, either the numerator or the denominator of the answer that we were looking for. But you're not always going to get it like that. Most of the time, you're just going to have a fraction that you could change to smaller numbers, so it would be just easier to understand pictorially. If I had 2/8, it would be a lot easier to see as 1/4. So this answer, or this way of saying the picture that is the same, but it's easier to understand it as 1/4 than 2/8. It's easier to picture it. So when we're working with numbers that could be expressed in smaller numbers, we call that simplifying the fraction or reducing it to its lowest terms. And you usually don't get one of the helpy answers on the reduced side. So this is the opportunity to review our numbers for divisibility to help us decide what number goes into the top, the numerator, and the denominator. Remember, we use the same one. We either multiply or we divide by the same number. In this case, we are going to make these numbers smaller if we can, so it's always going to be a division problem. If we look at the top and the bottom number, we can ask ourselves these same questions that we did for divisibility in another exercise. Are both of those numbers even? Yes, they are. You could use a 2. A 4, 6, or 8 might work, but 2 will. So we could divide this fraction by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. Check this out. Are these both numbers, are they even? No. Do they both end in a 0 or a 5? No. Will 3 work in the 2 or the 5? We would add the digits, but these digits are just singles. 3 or 9 will not divide into 2 or into 5, so skip that. Is it divisible by 7? No. And all of these two numbers are larger than, or are smaller than all of the primes that we've talked about before. So this particular fraction is what we call in lowest terms. If we went on, 3/24, we're going to divide by something. Are they both even numbers? No. 3 is odd. Do they end in a 0 or a 5? No. Are they twin double digits? No. Will 3 work? Well, we know 3 works in the top because it's 3. Let's add the digits of the 24. 2 plus 4 is 6, and 3 will divide into 6. So we can use a 3 for this number. Now we're going to just apply the math. 3 divided by 3 is 1. 24 divided by 3 is 8. Whenever your fraction has a 1 in the top, it is in lowest terms. Next one. Are these even numbers? Yes, they are. So 2 automatically works. 2 divides into 6 3 times. 2 divides into 8 4 times. Whenever your fraction is in counting order, so if you were to count 1, 2, 3, 4, 5, 6, 7, okay, so that's in counting order. If you had like 99 100ths or 70 71sts, you would know that your fraction is in lowest terms. Are these even? No. Do they end in a 0 or a 5? Yes. 5 works with numbers that end in a 0 or a 5. So we can divide these by 5. 5 divides into 25 5 times. 5 divides into 40 8 times. Let's see if this is in the lowest terms. Are both the numbers even? No. End in a 0 or a 5? No, they both have to. Will 3 divide into those numbers evenly with no remainder? No. 7? No. It's in lowest terms because all of the other primes are larger than are the numbers that we have, so you can't divide those. Let's come to this. 14 and 35. Are they both even numbers? No. Do they both end in a 0 or a 5? No. Add the digits. I'm sorry, are they twin double digits? No. Let's add the digits to check for 3 or 9. 1 plus 4 is 5. 3 will not divide into 5 evenly, so we'll skip that one. Could we divide this by 7? Well, 14 and 35 are both in the 7's line, so yes. 7 divides into 14 2 times. 7 divides into 35 5 times. Both of these, does that jump out at you, end in a 0? We can use a 10 for this. 5's going to work. 10 will work faster. So let's divide this by 10. 10 divides into 20 2 times. 10 divides into 50 5 times. Whenever you're dividing by 10, if you have zeros in the top and the bottom, you could cross out 1 0 from the numerator, 1 from the denominator, and that's your answer. See the 2/5? Boop. Last one. Are they even numbers? No. Zeros or 5s? No. Twin double digits? Yes, they are. So we could divide this by 11. 11 divides into 44 4 times. 11 divides into 77 7 times. The divisibility rules work really, really well when you're reducing fractions, renaming them, doing equivalent fractions to the lowest terms.